Welcome to Sleep Gazers, where science drifts into dreams. Close your eyes, relax your mind, and let the universe whisper you to sleep. Halo of silence, floating beyond the edge of the Milky Way. Hello there, and welcome to another quiet journey through the cosmos. Tonight, we're going somewhere most people never think to look. Not toward the bright center of our galaxy, where stars crowd together in brilliant clusters, their light mingling into a luminous haze that outshines everything around them. Not even toward the spiral arms, those graceful curves of glowing gas and newborn stars, where the galaxy does its most dramatic work, creating suns by the thousands, painting space in shades of crimson and sapphire and gold. Tonight, we drift outward, beyond the familiar, beyond the busy neighborhoods of stars, beyond the regions that appear in glossy photographs and fill astronomy textbooks with their vibrant colors and dynamic processes. We're traveling to the edge of the Milky Way, to a place called the galactic halo, a region so vast and so empty that silence itself seems to take physical form, to become something you could almost reach out and touch if your hand could span the distance between stars. If you're settling in for sleep, that's perfect. That's exactly where you should be. Let your body sink a little deeper into wherever you're resting. Feel the weight of the blankets, the support of the mattress or cushions beneath you, the way gravity gently pulls you down. The edge of the galaxy is no place for hurry. Out there, time moves differently. Distances stretch beyond easy comprehension. And in that stretching, in that vast quietness, there's a particular kind of peace that's difficult to find anywhere else in the universe. You don't need to remember every detail I share tonight. You don't need to take notes or quiz yourself later or worry about whether you're absorbing the information properly. Think of this more as drifting, like floating on calm water under a night sky, feeling the gentle motion beneath you, watching stars wheel slowly overhead while your mind wanders wherever it wants to go. The facts and the wonder will wash over you gently. Some will stick, settling into your memory like sediment drifting to the ocean floor. Others will dissolve into sleep, and that's not a loss. That's their purpose. Both outcomes are perfectly fine. Better than fine. They're exactly right. Take a breath now, a slow one. Let it fill your lungs completely, feeling your chest and belly expand. And then let it out, even slower than it came in, releasing any tension you might be holding in your shoulders, your jaw, the small muscles around your eyes. Good. Do that once more if you'd like. Breathing is something we do automatically, without thinking. But sometimes it's nice to notice it, to feel the simple rhythm of air moving in and out, the way it connects you to the space around you, the way it's been connecting living things to the universe for billions of years. Now, join me as we leave the bright disk of the Milky Way behind, traveling outward into the halo of silence that surrounds our galactic home. This is a journey measured not in kilometers or miles, but in light years. Distances so vast that light itself, moving at 300,000 kilometers per second, takes thousands and thousands of years to cross them. But we're not bound by such limitations tonight. In imagination, in the realm of thought and wonder, we can travel as fast or as slow as we like. We can cross 100,000 light years in a single breath. Or we can take our time, noticing every detail along the way. Let's start slowly. Let's begin where we are. Right now, at this very moment, you're somewhere on Earth. Maybe you're in a bedroom with familiar walls around you. Maybe you're in a living room, or sitting in a comfortable chair, or lying on a couch with a soft blanket pulled up to your chin. Wherever you are, you're on the surface of a planet. A rocky world about 12,700 kilometers in diameter, spinning on its axis once every 24 hours, orbiting a middle-aged yellow star once every 365 days. That star, our sun, is nothing special in the cosmic scheme of things. It's one star among hundreds of billions in our galaxy. Not the largest. There are stars hundreds of times more massive. Not the smallest. There are dim red dwarfs, barely a tenth of its size. Not the brightest, not the oldest, not the youngest. Just a star. An ordinary, unremarkable star doing what stars do. Fusing hydrogen into helium in its core, releasing energy that has traveled for 8 minutes across the void to warm your face on a sunny afternoon. Our sun, and Earth with it, and all the other planets in our solar system, live in a specific neighborhood of the Milky Way. We're located in one of the spiral arms, the Orion arm, sometimes called the Orion Spur, a smaller branch between two major arms. We're about 27,000 light-years from the galactic center, roughly halfway out from the core to the edge of the visible disk. It's a relatively quiet spot, far enough from the crowded center to avoid the chaos of too many stars packed too close together, but not so far out that we're isolated in the galactic suburbs where stars become sparse and lonely. This location, this particular spot in the galaxy, is where almost everything you can see with your naked eye exists. On a clear night, far from city lights, you can see perhaps 3,000 stars scattered across the sky. Every single one of them is in our local neighborhood, within a few hundred light years at most. The farthest star you can see without a telescope is probably less than 1,000 light years away. In galactic terms, that's nothing. It's like standing in your front yard and only being able to see your immediate block. All those stars, Sirius, Vega, Arcturus, Betelgeuse, all the familiar names that have guided travelers and inspired poets for thousands of years. They're all residents of the galactic disk, this flat spinning structure about 100,000 light-years from edge to edge, and roughly 1,000 light-years thick through most of its span. If you could shrink the Milky Way down until the entire galaxy was the size of a dinner plate, the disk would be like a crepe. Much wider than it is tall, thin but substantial, containing most of the matter you can see. This is where the action happens. This is where you'll find the molecular clouds, those enormous regions of gas and dust, where new stars are being born right now, this very second. As you listen to these words, this is where supernova explosions scatter heavy elements across space, seeding future solar systems with the building blocks of planets and people. This is where open star clusters blaze with the light of young, hot, brilliant suns that won't live for more than a few million years before burning out in spectacular fashion. The disk is busy. The disk is young, at least in its central regions where star formation continues. The disk is where galaxies do their most visible work, their most dramatic performances. It's the stage where cosmic events play out with light and fury and breathtaking scale. But the halo is different. Imagine now that you're beginning to rise. Not physically, of course. Your body remains exactly where it is, comfortable and warm and safe. But in your mind's eye, picture yourself lifting up from Earth's surface. You pass through the atmosphere in seconds, leaving behind the blue sky and the clouds, entering the black of space where stars don't twinkle because there's no air to make them shimmer. You glide past the moon, that faithful companion that's orbited Earth for over 4 billion years. You continue outward, past the orbit of Mars, past the asteroid belt with its tumbling rocks, past mighty Jupiter with its swirling storms and retinue of moons. You're leaving the solar system now, passing the outer planets, Saturn with its glorious rings, Uranus tilted on its side, Neptune in its distant cold orbit. You pass the Kuiper Belt where Pluto lives among thousands of other icy bodies. You pass the heliopause, the boundary where the solar wind finally gives way to the interstellar medium. You're in interstellar space now, the realm between stars. But you're still firmly within the disk of the Milky Way. Keep rising, keep moving upward, perpendicular to the galactic plane. From this vantage point, if you could look back, you'd start to see the structure of the disk itself. What appeared as the Milky Way from Earth, that band of light stretching across the night sky, would begin to resolve into its true form. A flat spiral of stars, with graceful arms curving outward from a bright central bulge. And as you rise higher, something begins to happen. Something subtle at first, almost too gradual to notice. The stars begin to thin. It's not that they disappear. It's not like crossing a border where on one side there are stars and on the other side there aren't. It's more gentle than that, more organic. Like walking from a dense forest where tree trunks crowd together and branches interlock overhead, blocking out the sky, into a more open woodland where trees still grow, but with space between them, where light filters down more easily, where you can see farther through the gaps, and eventually into a meadow where trees become occasional, then rare, then absent altogether. That's what happens as you rise above the galactic disk. The stars don't end. They simply become fewer, farther apart. The darkness between them grows wider, deeper, more profound. This is the beginning of the galactic halo. The halo isn't a place you can point to and say, it starts here at this precise distance from the galactic plane. It's not a boundary marked with a line or a sign. It's a transition, a gradient, a slow shift from one state to another. Astronomers define it in technical terms. They'll talk about scale heights and density profiles and exponential drop-offs. But the reality is simpler and more beautiful. The halo is where the galaxy thins into something else, something quieter. Let your imagination carry you higher still. You're thousands of light years above the disk now. And when you look down, the view has changed dramatically. The Milky Way, the galaxy that contains everything you've ever known, every human who has ever lived, every star you've ever seen, has become a distant object. A structure you can perceive as a whole rather than something you're embedded within. It's vast, even from this distance. The spiral arms are visible now, trailing outward from the central bulge like cream stirred into coffee, frozen in a moment of graceful rotation. There's the Perseus arm, one of the major structures. There's the Sagittarius arm, pointing toward the galactic center. And there, barely visible from this angle, is the Orion Spur, where the sun resides, where Earth resides, where you reside. Though from here it's lost in the glow of billions of other stars. Indistinguishable, invisible, one tiny point of light among a multitude. The central bulge dominates the view, that dense spherical region at the galaxy's heart, where stars pack together far more tightly than in the disk. At the very center, invisible from here, lurks Sagittarius A, the supermassive black hole that anchors the entire structure, 4 million times more massive than our sun, its gravity reaching outward to influence the orbits of millions of stars. But around all of this, surrounding the bright disk, encompassing the bulge, extending far beyond where the spiral arms fade into darkness, is something else. Something harder to see, easy to miss if you don't know to look for it, but absolutely essential to understanding what a galaxy truly is. The halo not dark, not quite. Scattered throughout this vast region, like seeds blown across an endless field, are stars, but such different stars from those in the disk below. You can see them if you let your eyes adjust to the darkness, if you're patient enough to notice the faint points of light that dot the space around the galaxy. They're dim, they're red, and they're old, unimaginably old. Many of these stars formed more than 10 billion years ago, back when the universe itself was young, before the Milky Way had even settled into its current spiral form. They witnessed the galaxy's violent early days, when smaller proto-galaxies merged and collided, when star formation proceeded in chaotic bursts rather than the relatively orderly processes we see in the disk today. They've been orbiting through this halo ever since, following long elliptical paths that carry them far above and below the galactic plane, taking hundreds of millions of years to complete a single orbit around the galactic center. These are the galaxy's elders, its oldest citizens, and unlike the stars in the disk, which mostly orbit in the same direction, following the galaxy's rotation like cars on a cosmic highway, these halo stars move in all directions. Some orbit one way, some orbit the other way. Some travel in nearly polar orbits, plunging through the disk and out the other side. Their motion is random, chaotic, like bees around a hive rather than planets around a sun. This randomness tells a story. It tells us that these stars formed in a different environment, under different conditions, from different material than the stars that populate the disk. They're not native to the organized, rotating structure of the modern Milky Way. They're immigrants, survivors, refugees from a more chaotic time in galactic history. And they're spread across an enormous volume of space. The disk of the Milky Way, as we mentioned, is about 100,000 light-years in diameter and roughly 1,000 light-years thick in most places. It sounds huge, and it is. Crossing from one side to the other at the speed of light would take 100,000 years. But the halo is larger, much larger. The halo extends perhaps 300,000 light-years from the galactic center, 3 times the width of the visible disk. And it's not flat like the disk. It's roughly spherical, surrounding the galaxy on all sides. If the disk is a crepe, the halo is the space around it, extending up and down and out in all directions. The total volume of the halo is dozens of times larger than the volume of the disk. But here's what makes the halo truly remarkable. Despite being so much larger, it contains far fewer stars. The density of stars in the disk varies depending on where you look. But in the solar neighborhood, there's roughly 1 star for every few cubic light years. In the halo, you might find 1 star per 1,000 cubic light years, or 10,000, or even more. The stars are spread so thin that the space between them becomes the dominant feature. It's the emptiest inhabited place in the galaxy. If you were somehow standing on a planet orbiting one of these ancient halo stars, the night sky would be remarkably dark. You wouldn't see the Milky Way as a glowing band across the heavens. From the halo, the galactic disk would appear as a distant spiral structure, beautiful but remote, like a pinwheel of light hanging in the cosmic distance. You might see Andromeda, the nearest large galaxy, perhaps even more clearly than we see it from Earth. Because without the light pollution from billions of nearby stars, your view would be remarkably unobstructed. But nearby stars? There would be hardly any. The nearest stellar neighbor might be hundreds or thousands of light years away. Distances that seem impossible to bridge. Gaps that emphasize the profound isolation of these ancient suns. And yet, there's a beauty in that isolation, a peacefulness. The halo stars don't jostle for position. They don't compete for space or resources. They simply exist, burning their fuel at a slow, steady rate, following their long orbits through the darkness, patient in a way that nothing in the busy disk can match. From your vantage point high above the galaxy, you can begin to appreciate the scale of what you're looking at. The disk, with all its activity and drama, is a tiny portion of the total structure. The halo, this vast, dark, nearly empty region, is what defines the true extent of the Milky Way. It's the majority of the galaxy's volume, even though it contains a tiny fraction of the visible stars. But it doesn't contain a tiny fraction of the galaxy's mass. Not even close. Because the halo holds a secret. Something invisible. Something we can only detect through its gravitational effects, the way it bends light and influences the motion of visible matter. Something that, according to our best measurements, makes up perhaps 90% of the galaxy's total mass. Dark matter. It's a placeholder name, a term that means we don't know what this is, but we know it's there. Dark matter doesn't emit light, that's why it's called dark. And it doesn't absorb light, doesn't reflect light. As far as we can tell, it doesn't interact with light or normal matter at all, except through gravity. But its gravitational influence is undeniable and profound. Without dark matter in the halo, the Milky Way would quite literally fly apart. The visible matter in the disk, all those stars and gas clouds, is rotating so fast that the gravity from that visible matter alone isn't enough to hold everything together. The outer regions should be flung into space like water droplets spinning off a wet wheel. But they're not. Something's holding them in place. That something is the dark matter halo, an enormous invisible cloud of something that surrounds and permeates the galaxy, providing the gravitational glue that keeps everything bound together. We can map its distribution by observing how it affects the motion of stars and gas. We can measure how much of it there must be based on how fast things are rotating. We can even see it bend the light from more distant galaxies through a process called gravitational lensing. But we can't see the dark matter itself. It's there, all around the galaxy, making up the vast majority of the halo's mass, but invisible, intangible, present only through absence, like the invisible ocean we can only detect by watching how boats float on its surface. It sounds mysterious, and it is. Dark matter is one of the biggest unsolved puzzles in modern astrophysics. Physicists have proposed dozens of theories about what it might be. Exotic particles with names like WIMPs and axions, or perhaps even primordial black holes left over from the Big Bang, or stranger things we haven't thought of yet. Deep underground, in laboratories shielded from cosmic rays, detectors wait in the darkness, hoping to catch the faint signal of a dark matter particle passing through normal matter. An event so rare and subtle that you need equipment sensitive enough to detect a single atomic nucleus recoiling from the impact. So far, those detectors have found nothing conclusive. Dark matter remains elusive, refusing to reveal its true nature. But you know what? That mystery isn't frightening. It isn't threatening. If anything, it's oddly peaceful. The universe is reminding us that there's still so much we don't know, so much still to discover. The darkness isn't empty. It's full of quiet things we're still learning to perceive. Full of matter that doesn't shout its presence, but influences everything around it through patient, steady gravitational attraction. The halo, in other words, is mostly made of mystery. And that mystery is what holds the galaxy together. Let that thought settle for a moment. You don't have to understand it completely. You don't have to be able to explain it to someone else. Just let the idea rest in your mind. The Milky Way, the galaxy that contains our entire civilization, is held together by something invisible, by darkness made substantial, by the quiet presence of matter that doesn't need to shine to be important. There's a lesson in that, perhaps. Not everything valuable is visible. Not everything important needs to announce itself. Sometimes the most essential things are the quietest, the most patient, the most easily overlooked. The halo surrounds us, always. Even now, as you rest in your comfortable spot, you're inside the halo's domain. The disk where we live is just the bright center of a much larger structure. We're wrapped in this enormous cloud of dark matter and ancient stars, held gently in place by invisible gravity, embraced by a silence that extends for hundreds of thousands of light years in every direction. You can't see it. You can't feel it directly. But it's there, patient and constant, like the air in your lungs or the ground beneath your feet, so fundamental that you rarely think about it, but essential all the same. As you drift higher in imagination, leaving the last of the disk's scattered stars behind, the darkness deepens. Not a threatening darkness, never that. This is the darkness of deep space, the darkness between galaxies, the primal darkness that filled the universe before the first stars ignited. It's peaceful. It's clean. It's infinite in a way that earthbound darkness can never be, because it's uncontaminated by any light source, unbroken by any horizon. This is where silence lives. This is where stillness becomes not just the absence of motion, but a presence in itself. Out here, in the galactic halo, you're farther from the noise and bustle of stellar nurseries than most minds can easily grasp. The nearest star might be 10,000 light years away. The nearest active region of star formation might be 100,000. You're in a place where cosmic events happen on timescales that make human history seem like an eye blink. And yet, even here, even in this almost empty darkness, you're not alone. Not completely. Because the halo has residents, permanent inhabitants who have claimed this quiet realm as home. And as we float here together, suspended in this imaginary space above the galaxy, we can begin to notice them, to see what lives in the silence. But perhaps we'll save that discovery for a moment. For now, just float here, just drift. Feel the vast emptiness around you, not as something to fear, but as something to marvel at. The galaxy below glows softly, a spiral of light in the darkness. Ancient stars glimmer faintly in the space around you. Dark matter flows invisibly through everything, holding the structure together with patient gravity. And you're here, imagining yourself at the edge of everything familiar, in a place where silence is infinite and time moves in measures of millions of years. Let that peace wash over you. Let your breathing slow to match the patient rhythm of this place. There's no hurry here. There never is. In the halo, rush and urgency are foreign concepts, meaningless words from a distant world. Rest here for a moment. We have farther to go, more to discover. But right now, this is enough. The journey itself is the destination. The halo welcomes you. It always has. You're wrapped in its embrace, held in its silence, surrounded by its patient darkness. And that's exactly where you're meant to be. So here we are, floating in the galactic halo, suspended in that vast darkness between the bright disk below and the empty space beyond. You might think that a place this empty, this quiet, would have nothing to show us. That once we've noticed the ancient stars scattered thinly through the void, there would be nothing left to discover. But the halo, it turns out, has secrets. Treasures hidden in the darkness. Structures and objects that reveal themselves only to patient observation. those willing to look carefully at what seems, at first glance, to be nothing at all. Let's begin with something spectacular. Something that, if you could see it up close, would take your breath away, even as it filled you with a sense of profound time and cosmic history. Globular clusters. The name sounds technical, perhaps a bit cold. But what it describes is anything but cold. Imagine a sphere of stars, not spread thin like the stars in the halo around you, but packed together in a dense ball. A three-dimensional cluster where stars orbit their common center of gravity, held together by mutual attraction, circling each other in an intricate gravitational dance. Now imagine that this sphere contains not dozens of stars or hundreds, but thousands, tens of thousands, sometimes hundreds of thousands of stars, all bound together in a structure perhaps 100 light years across. From a distance, a globular cluster looks like a fuzzy ball of light, a soft glow against the darkness. But if you could drift closer, if you could approach one of these ancient cities of stars, the view would resolve into something extraordinary. Stars. Everywhere you look, stars. Not evenly spaced like they are in the disk, where the nearest stellar neighbor might be several light years away, but crowded together. In the outer regions of a globular cluster, stars might be separated by just a single light year, maybe less. And toward the center, toward the dense core where gravity pulls hardest, the separation shrinks to light months or even light weeks. Tens of thousands of stars packed into a space that, by galactic standards, is incredibly small. If you were standing on a planet in the heart of a globular cluster, and it's unclear whether planets even form in such environments. Given how different the conditions are from the quieter regions where Earth formed, the night sky would be almost unrecognizable. Instead of the familiar scattered points of light we see from Earth, you'd see thousands of bright stars, close enough that some would cast visible shadows. The sky would never be truly dark. There would be no Milky Way band stretching overhead, because you wouldn't be in the disk. Just stars, brilliant and numerous, surrounding you on all sides. It would be beautiful, overwhelming perhaps. A reminder that the universe can pack a matter together in ways that seem almost impossibly dense compared to the space we're used to. But also a reminder that even in density, there's order. The stars in a globular cluster don't collide randomly. They follow precise orbital paths, balanced by gravity, stable over billions of years. And billions of years is exactly how long these structures have existed. Globular clusters are old, not just old, ancient. Most of them formed between 10 and 13 billion years ago, back when the universe itself was only a few billion years old, when the Milky Way was still assembling itself from smaller pieces, when the cosmic web of galaxies was just beginning to take shape. They're among the oldest structures in our galaxy, the oldest visible objects we can point to and say, that was here near the beginning. The stars within them are old, too. You won't find any of the hot blue giants that populate the spiral arms, the stars that burn fierce and bright and die within a few million years. Those stars used up their fuel and exploded as supernovae billions of years ago. What remains are the long-lived stars, the red dwarfs that burn so slowly they might last for trillions of years, the yellow stars like our sun but much older, the red giants that have already exhausted their core hydrogen and expanded to enormous sizes as they begin their final decline. If stars could grow tired, these would be tired. Not extinguished, not yet, but showing their age. Burning steadily, faithfully, as they have for longer than complex life has existed on Earth. For longer than Earth itself has existed. They were already ancient when our solar system was still a cloud of gas and dust, not yet collapsed, not yet ignited, just potential waiting to become reality. There are about 150 to 200 globular clusters orbiting the Milky Way. That number is approximate. Some are faint and easy to miss, especially if they're on the far side of the galaxy from our perspective. But each one is a world unto itself, a dense sphere of stars following its own long orbit through the halo, swooping down through the galactic disk and back up into the emptiness on the other side, taking hundreds of millions of years to complete a single circuit. From where we're floating, high above the disk, you might be able to see a few of them. They appear as faint, fuzzy spots, brighter than individual stars, but still quite dim at these distances. Each one is an island of light in the darkness, a remnant from the galaxy's youth, preserved almost unchanged for billions of years. The most famous globular cluster visible from Earth is Messier 13, sometimes called the Great Globular Cluster in Hercules. On a dark summer night, from a location far from city lights, you can just barely see it with the naked eye. A faint smudge of light in the constellation Hercules. Through a telescope, it resolves into a spectacular ball of stars, with the densest concentration at the center and long streamers of stars extending outward. It contains perhaps 300,000 stars, all orbiting each other, all born from the same cloud of gas in the early universe, all aging together like an ancient family that has stayed close for billions of years. But here's what makes globular clusters even more remarkable. They're survivors. The Milky Way has probably had many more globular clusters in the past than it does now. As these clusters orbit through the galaxy, they occasionally pass close to the dense regions of the disk or near the galactic center. When that happens, tidal forces, the same forces that cause ocean tides on Earth, but on a vastly larger scale, can tear stars away from the cluster's outer regions. Over billions of years, over hundreds of orbits, a globular cluster can lose a significant fraction of its stars to these tidal stripping events. Some clusters have been completely destroyed this way, their stars scattered and mixed into the general stellar population of the halo. Others have been reduced from their original sizes, but persist, still bound together, still maintaining their identity as distinct objects. The ones we see today are the resilient ones, the survivors who have navigated the gravitational hazards of the galaxy for billions of years and remained intact. They're islands, as we said, islands of light in an ocean of darkness. And like islands, they're isolated from each other. The nearest globular cluster to any given cluster might be tens of thousands of light years away. They're scattered throughout the halo in a roughly spherical distribution, orbiting the galaxy independently, only rarely coming close enough to each other to interact gravitationally. If you were living in one globular cluster and wanted to visit another, the journey would be almost unthinkably long. Even traveling at the speed of light, which, remember, is impossible for anything with mass, it would take tens of thousands of years to reach the nearest neighboring cluster. For any civilization that arose within a globular cluster, assuming that's even possible, the isolation would be profound. They would be surrounded by their own stars, thousands of companions in their own cluster. But the rest of the universe would seem impossibly distant, unreachable. Perhaps there's a strange comfort in that isolation, to be surrounded by your own kind, your own family of stars, while the vast, empty darkness keeps everything else at bay. To live in density and intimacy, knowing that beyond the edges of your stellar city lies not more city, not suburbs or neighboring towns, but endless empty space. It's a different kind of existence from what we experience in the disk. used to thinking of stars as individuals, scattered through space with vast gulfs between them. But in a globular cluster, community is the defining feature. Stars so close together that they can affect each other's evolution, sometimes even stealing matter from companions or colliding in rare, spectacular events. And yet, despite that closeness, despite being packed into a relatively small volume, the stars in a globular cluster don't orbit chaotically. They follow regular paths determined by the collective gravity of all the other stars, each one influencing every other one, creating a self-organizing system that has remained stable for billions of years. It's a kind of cosmic harmony, thousands of individual voices blending into a single, coherent structure. But globular clusters, as remarkable as they are, represent only the visible portion of what lives in the halo. They're the islands you can see. What about the ocean itself? What fills the vast spaces between the clusters, between the scattered ancient stars, in all that darkness that dominates the halo's volume? We've already mentioned dark matter, that invisible, intangible substance that makes up most of the halo's mass. It's there, flowing through everything, holding the galaxy together, but offering nothing to see, nothing to hear, nothing to touch. It's the ultimate background presence, essential but imperceptible. But there's something else, something visible if you know how to look for it. Something that tells a story about the galaxy's history, about violence and transformation and the slow mixing of matter across cosmic time. Stellar streams. Imagine pulling taffy. You start with a compact lump, and as you stretch it, it elongates, getting longer and thinner, forming a ribbon that connects where it started to where you've pulled it. Stellar streams are like that, except the taffy is made of stars, and the pulling is done by gravity, and the process takes not seconds, but billions of years. Here's how they form. A small galaxy, or sometimes a globular cluster, orbits the Milky Way. It's not part of the Milky Way, not yet. It's a separate structure, with its own stars, its own dark matter, its own identity. But it's close enough that the Milky Way's gravity affects it. As this small galaxy moves through its orbit, tidal forces pull on its outer stars. The stars on the side closer to the Milky Way feel slightly stronger gravity than the stars on the far side. This difference in gravitational pull is small, but over millions and billions of years, it adds up. Slowly, stars begin to get pulled away from the small galaxy. They're stripped off the outer edges and left behind in the smaller galaxy's orbital path. More orbits, more stripped stars. Eventually, the small galaxy itself might be completely torn apart, its stars scattered along the stream, marking the path it traveled through the halo. What's left is a stellar stream, a long, thin ribbon of stars, sometimes stretching for hundreds of thousands of light years, all following roughly the same orbital path, all remnants of a structure that no longer exists as a coherent object. From our floating vantage point in the halo, if we had eyes sensitive enough, we might be able to see these streams. They're faint. The stars in them are spread thin, and they're typically old, dim red stars that don't shine brightly. But they're there, winding through the darkness like cosmic rivers, like trails of breadcrumbs marking where something once traveled. The Milky Way has dozens of known stellar streams, and probably many more that haven't been discovered yet because they're too faint or too diffuse to detect easily. Each one has a name, usually derived from either the constellation where it's most visible or from the galaxy or cluster it came from. There's the Sagittarius stream, the remnant of the Sagittarius dwarf elliptical galaxy, a small galaxy that's currently in the process of being torn apart by the Milky Way. wraps around the entire galaxy, visible in both the northern and southern hemispheres of the sky. The Sagittarius dwarf itself still exists, a compact clump of stars still holding together despite the tidal forces. But it's been stripped of most of its original mass. Eventually, probably in another billion years or so, it will be completely dissolved, its stars fully mixed into the Milky Way's halo. There's the orphan stream, so named because astronomers found the stream before they found the galaxy or cluster that created it. It's a long arc of stars in the northern sky, clearly the remnant of some disrupted object. But the progenitor, the original structure, has either been completely destroyed or is too faint to identify. It's an orphan in the sense that we can see the children, the stars in the stream, but not the parent, whatever structure they came from. There's the Monoceros ring, a controversial structure that might be a stellar stream or might be something else. A warping of the galactic disk, perhaps, caused by interactions with satellite galaxies. Astronomy isn't always neat and certain. Sometimes we find structures that don't fit easily into our categories, that blur the lines between different types of cosmic objects. The point is, the halo is crisscrossed with these ghostly trails, evidence of the Milky Way's history as a cannibal, a larger galaxy that has grown over billions of years by consuming smaller neighbors. It sounds violent when described that way, but the reality is far more gentle. The merging of galaxies happens slowly over millions and billions of years. Stars from the smaller galaxy don't collide with stars in the Milky Way. Space is too vast, stars too small for collisions to be likely. Instead, the smaller galaxy stars are simply redistributed, mixed into the larger structure, given new orbits in their new home. It's like a drop of ink in water. At first, the drop is distinct, separate, recognizable. But over time, it spreads, diffuses, mixes, until the distinction between the ink and the water becomes impossible to define. The stars from consumed galaxies become part of the Milky Way, indistinguishable from stars that formed here originally. But for a time, a long time by human standards, but brief by cosmic standards, we can still see the streams, the traces of where they came from, the paths they traveled. These streams are memory, the galaxy's memory of its own history, written in stars. Each stream tells a story of a merger, of a smaller galaxy or cluster that wandered too close and was pulled apart by tidal forces. By studying the streams, measuring the positions and velocities of their stars, determining their chemical compositions, modeling their orbits backward in time, astronomers can reconstruct what happened, sometimes billions of years ago. They can identify when the merger occurred, what kind of object was consumed, where it came from, how massive it was. It's cosmic archaeology. Instead of digging in the ground for pottery shards and ancient tools, astronomers dig in the sky for stellar streams and chemical signatures. Both tell stories about the past. Both reveal how the present came to be. And here's something beautiful. You are made of this history, not metaphorically, literally. Some of the atoms in your body, the carbon and oxygen and nitrogen and iron, were formed in stars that once belonged to galaxies that no longer exist. Small galaxies that merged with the Milky Way billions of years ago. Their stars scattered into streams, eventually exploding as supernovae and seeding the interstellar medium with heavy elements. Those elements mixed with gas clouds, which eventually collapsed to form new stars and planets, including our Sun and Earth. You carry within you the remnants of galaxies that were destroyed before Earth existed. Your atoms are older than the solar system, and some of them have traveled a long, strange path to end up where they are now. arranged into a living, breathing, thinking being, lying comfortably somewhere on Earth, listening to words about the halo of silence at the edge of the Milky Way. That's not fantasy. That's just cosmic recycling, the way matter moves through the universe, getting reused over and over, taking on new forms, telling new stories, but never truly disappearing. There's one more type of object in the halo worth mentioning, though they're rare. So rare that only a few dozen have been discovered, despite astronomers searching for them for years. Hypervelocity stars. The name tells you most of what you need to know. These are stars moving fast, incredibly fast. Fast enough to escape the Milky Way's gravity entirely and fly off into intergalactic space. We're talking speeds of 1,000 kilometers per second, sometimes more. For comparison, our sun orbits the galactic center at about 220 kilometers per second, which seems fast until you realize it's nothing compared to these cosmic speedsters. How does a star get moving that fast? The most common mechanism involves the supermassive black hole at the galaxy's center, Sagittarius A. Occasionally, a binary star system, two stars orbiting each other, wanders too close to the black hole. The intense gravity in that region can disrupt the binary, capturing one star while flinging the other one away at tremendous speed. It's like a gravitational slingshot, converting the orbital energy of the binary system into velocity for the ejected star. That star goes flying. It tears through the disk, moving so fast that the galaxy's gravity can barely slow it down. Eventually, it reaches the halo, still moving at incredible speed, and continues outward. Some of these hypervelocity stars will escape the Milky Way entirely, becoming lonely wanderers in the vast space between galaxies. Others will slow down just enough that they remain bound to the galaxy, but their orbits will carry them millions of light years from the disk before gravity turns them around, and they begin the long fall back. From our perspective, floating in the halo, we might see one of these stars flash past. Though flash is relative when we're talking about cosmic distances. Even at 1,000 kilometers per second, a star takes thousands of years to cross the space between one arbitrary point in the halo to another. But by stellar standards, by the standards of objects that usually take millions of years to noticeably change position, hypervelocity stars are racing. There's something poignant about them. They're refugees, in a sense. Stars that were torn from their companions, flung away from the only home they knew, sent flying through the darkness of the halo. They'll spend the rest of their lives, which could be billions of years, alone, far from the busy neighborhoods of the disk, far from other stars, with nothing but the emptiness of the halo for company. But maybe that's not a sad fate. Maybe there's a kind of freedom in it, to be unbound, or nearly so, to move through space at speeds that nothing else can match. Not through any effort of your own, but simply because of the accident of your birth, or the chance of your orbit bringing you too close to a black hole. To see parts of the galaxy that stationary stars never see. To climb higher into the halo than almost anything else. To look down on the disk from perspectives that most stars never experience. There's more than one way to think about it. The stars in the halo, whether they're the ancient members of globular clusters, the scattered remnants in stellar streams, or the rare hypervelocity escapees, all share something in common. They're far from the action, far from where new stars are being born, where supernovae are exploding, where the drama of galactic evolution plays out most visibly. They're in the quiet place, the slow place, the place where time stretches long and distances make interaction unlikely. And yet, they persist. They shine, dim though many of them are. They orbit, following their gravitational paths with patient precision. They exist as part of the galaxy's structure, even though they're separated from the bright central regions by vast gulfs of space. There's a lesson there, maybe, about persistence, about continuing to shine even when you're far from others, even when the space around you is mostly empty. The halo stars don't need an audience. They don't need validation or attention. They just exist, burning their fuel, following their paths, participating in the slow dance of galactic mechanics. In the halo, simply being is enough. Let's drift here for a moment longer. Let's float in this space between the globular clusters, among the faint traces of stellar streams, in the region where hypervelocity stars occasionally flash past on their way to who knows where. The darkness is profound here. The silence is complete, not because there's no sound. Space never has sound. There's no medium for it to travel through. But because the emptiness itself seems to absorb noise, to swallow disturbance, to enforce a kind of cosmic hush, you might think that emptiness would feel oppressive, that being surrounded by so much nothing, so much distance, so much space, would create a sense of isolation or loneliness. But it doesn't. Or at least, it doesn't have to. Think of it instead as spaciousness, room to exist without crowding, freedom from the pressure of too much matter packed into too little space. The halo offers something that's increasingly rare in the universe: true openness, true quiet, a place where the next object you might interact with is so far away that interaction is effectively impossible, where you can exist as yourself, following your own path without being pushed or pulled or forced to conform to the needs of a dense stellar neighborhood. There's a peace in that, a strange cosmic peace that comes from being unconfined. The dark matter flows through this space, invisible and intangible, providing the gravitational framework that gives structure to everything. It doesn't demand attention. It doesn't insist on being noticed. It just is, present and essential, holding the galaxy together through patient, steady attraction. The ancient stars drift on their long orbits, taking hundreds of millions of years to complete a single circuit around the galactic center. They're not in a hurry. They've been doing this for billions of years. They'll continue doing it for billions more. What's the rush? And you're here, floating in imagination through this vast emptiness, feeling the scale of it, the depth of it, the quiet of it. Your body is still where it was, comfortable, warm, safe, supported by whatever you're lying or sitting on. But your mind has traveled far, farther than light could travel in a human lifetime. You've come to a place where silence isn't just the absence of sound, but the presence of peace. Breathe it in, this imaginary air of the halo, this peaceful darkness, this patient emptiness. There's more to explore, more wonders hidden in the halo's vastness. But we're not in a hurry either. We can drift here as long as we like. We can let the darkness hold us. We can float in the space between stars and feel the slow rotation of the galaxy beneath us. The ancient dance of gravity and matter that has continued for billions of years and will continue for billions more. Time doesn't press here. Distance doesn't threaten. The emptiness doesn't demand to be filled. Everything just is. Patient, quiet, still. And that's exactly as it should be. The halo welcomes those who seek silence, who need spaciousness, who want to float in the darkness for a while and remember that emptiness isn't lack, it's possibility. It's room. It's breath. So breathe, drift, rest. The ancient stars keep watch. The dark matter holds everything together. The streams trace their ghostly paths through the void. And you're part of this, connected to this. the same matter that makes everything else in the universe. You belong here as much as anywhere, in the halo of silence, where the galaxy thins and stillness becomes infinite. We've been floating here for a while now, you and I, suspended in imagination above the galactic disk, surrounded by the vast emptiness of the halo. We've talked about what lives here, the ancient stars, the globular clusters, the stellar streams, the invisible dark matter. We've named things, described things, tried to put numbers to things that are almost too large for numbers to capture meaningfully. But now, let's set the facts aside for a moment. Let's stop cataloging and naming and measuring. Let's simply experience what it would be like to be here. To truly be in the halo, in this place where emptiness is the dominant feature. Where silence isn't just absence, but presence. Where distance becomes something you can almost feel against your skin. What would it be like? Not as a fact, not as a scientific observation, but as an experience, as a feeling. Let's find out. First, let's talk about distance. Real distance. The kind that makes even the word far seem inadequate. From Earth, we think of the stars as distant, and they are. The nearest star beyond our sun, Proxima Centauri, is about 4.2 light years away. That's roughly 40 trillion kilometers, or about 25 trillion miles. It's a distance so vast that it takes light itself, moving at 300,000 kilometers per second, the fastest thing in the universe, over 4 years to cross it. But in the halo, that distance would seem almost intimate, almost neighborly. In the regions of the halo we're floating through, the nearest star might be not 4 light years away, but 400, or 4,000, or even more, depending on exactly where you are in this vast structure. Think about what that means for a moment. Really think about it. If you were standing on a planet orbiting a halo star, looking up at the night sky, trying to find the nearest stellar neighbor, that neighbor would be so far away that its light, traveling at the ultimate cosmic speed limit, would take thousands of years to reach your eyes. Thousands of years. Entire civilizations could rise and fall on Earth in the time it takes light from your nearest neighbor to arrive. And that's just the nearest one. The second nearest might be twice as far. The third nearest farther still. In our solar neighborhood, in the disk, stars are spaced such that if you could travel at the speed of light, you could visit dozens of stellar systems in a human lifetime. The galaxy would feel traversable, at least in principle. Vast, yes, but not impossibly so. You could imagine sending messages to nearby stars, receiving responses decades later. You could imagine, with sufficiently advanced technology, traveling to them. But in the halo, even imagination struggles. The distances are so extreme that interaction between stellar systems becomes essentially impossible. Even traveling at light speed, which, remember, is impossible for anything with mass, it would take millennia to reach even your closest neighbor. Sending a message and receiving a reply would take longer than recorded human history. The isolation is profound, complete, absolute. And yet, there's something about that isolation that isn't frightening, isn't sad. It's simply a fact of existence in the halo, as fundamental as gravity or time. If you were a being that had evolved on a planet orbiting a halo star, you wouldn't experience this isolation as deprivation. You wouldn't feel lonely because you'd never known anything different. You wouldn't long for nearby stars because there are no nearby stars. This would be normal. This would be home. The emptiness wouldn't be empty to you. It would just be, not space, the natural state of things. Maybe there's something to learn from that perspective, about how loneliness is often a function of expectation rather than reality, about how isolation only feels like isolation when you're comparing it to connection. If you've never known crowding, spaciousness doesn't feel like lack, it feels like freedom. Let your mind drift now to what you would see if you were really there, floating in the halo, far from the disk, far from the bright regions where most of the galaxy's light originates. The first thing you'd notice is the darkness. True darkness. Complete darkness. On Earth, even on the darkest night, far from any city, there's always some light. The moon, when it's up, provides enough illumination to see by. Even when the moon is down, there's starlight. Faint, yes, but enough to make out shapes, to navigate, to see your hand in front of your face. And there's always some light pollution somewhere. Even in the most remote places, the glow of distant cities reflects off the atmosphere, creating a faint background luminosity that never quite goes away. In the halo, there would be none of that. The nearest significant source of light would be the galactic disk itself, but from hundreds of thousands of light years away, it would appear as a distant spiral structure. Beautiful, certainly. Perhaps even spectacular. A glowing pinwheel hanging in the cosmic distance, its spiral arms traced out in blue and gold, its central bulge shining with the concentrated light of billions of stars. But it would be far away. So far away that its light would provide no useful illumination. It wouldn't cast shadows. It wouldn't light your way. It would just be there, in the distance, like a lighthouse seen from miles across a dark ocean. The Andromeda Galaxy might be visible too, another spiral hanging in space, similar to but distinct from our own Milky Way. From the halo, without light pollution, without atmospheric interference, Andromeda would be clearly visible to the naked eye. A smudge of light revealing itself as a galaxy when you looked at it carefully. And perhaps you could see other members of the local group, the small cluster of galaxies that includes the Milky Way and Andromeda, the Triangulum Galaxy, the Magellanic Clouds, if you were in the right part of the halo to see them, small companion galaxies orbiting the larger structures. But all of them would be distant. All of them would be faint. They would provide perspective, a sense of the larger cosmic structure. But they wouldn't provide light. Not useful light. Not light you could read by, or navigate by, or warm yourself with. The nearest stars, the other halo stars, your distant companions in this emptiness, would be visible, but there wouldn't be many of them. Depending on where you were, you might see a few dozen scattered across the entire sky, maybe 100 if you were in a relatively dense region. But they'd all be faint, dim red stars for the most part, ancient and cool, not blazing with the fierce light of young blue giants. The sky would be mostly dark, profoundly dark. The kind of darkness that makes you realize how unusual light actually is in the universe. How rare, how precious. Most of space, most of the volume of the cosmos, is darkness. Light is the exception, concentrated around stars and galaxies, but taking up an infinitesimally small fraction of the total space. In the halo, you'd be experiencing the norm, the default state of the universe. Darkness not as absence, but as presence, as the natural background against which the rare sparks of light become visible. And that darkness, it wouldn't be frightening. How could it be? It's peaceful, it's clean, it's honest. There's no deception in darkness, no hiding, no pretense. It simply is what it is. The space between light, the canvas on which light paints its rare pictures. You could float in that darkness forever, and it would never threaten you. It would just hold you, gently, patiently, like floating in a calm sea at night, suspended in water you can't see, supported by something that asks nothing of you except to let go. Now think about sound, or rather, the absence of it. Space, of course, has no sound. There's no air, no medium for sound waves to travel through. Even in the disk, surrounded by stars and nebulae and cosmic activity, there's no sound. Explosions are silent. Stars collapse without a whisper. Gas clouds collide in perfect quiet. But in the halo, the silence would somehow feel even more profound, because there would be so little activity. In the disk, at least, things are happening. Stars are being born. Supernova explosions are seeding space with heavy elements. Stellar winds are carving bubbles in the interstellar medium. There's motion, change, transformation, even if it all happens in silence. The halo, by contrast, is a place where change happens so slowly that it might as well not happen at all. The ancient stars burn at the same rate they've burned for billions of years. Their orbits carry them through space, but those orbits take hundreds of millions of years to complete. From any given moment to the next moment, you might observe, nothing has changed. Nothing has moved noticeably. Nothing has happened. It's not frozen. That's not the right word. Frozen implies that things could move, but are prevented from doing so. The halo is patient. Things move, but at a pace so slow that patience isn't a virtue. It's the only possible way to exist. If silence had a home, it would be here. Not the silence of holding your breath, which implies that noise might return any moment, but the silence of deep time, of cosmic scales, of distances too vast for interaction. The silence of things that simply exist, without needing to announce themselves, without needing to make noise or demand attention. You can feel that silence right now, even in your room, even with whatever small ambient sounds might be present. Close your eyes for a moment, or keep them open, it doesn't matter, and just notice the quiet. Not the absence of sound, but the presence of silence, the space between sounds, the gaps where nothing needs to happen, where nothing needs to be said, where existence doesn't require soundtrack or commentary. That's a taste of the halo's silence. That's what the emptiness sounds like. Nothing. And it's perfect. Time works differently in the halo. Or rather, your perception of time would be different. Not because time itself changes, it flows at the same rate everywhere, at least in the same gravitational field, but because there are so few events to mark its passage. On Earth, we measure time by change, by the rising and setting of the sun, by the phases of the moon, by the changing seasons, by the ticking of clocks and the movement of shadows and the growth of plants and the aging of our bodies. We're surrounded by markers of time's passage, constant reminders that moments are accumulating, that the present is becoming the past, that time is moving forward. In the halo, most of those markers would be absent. The stars would shine steadily, unchanging from night to night, year to year, century to century. Their light wouldn't flicker. They wouldn't move noticeably across the sky. Their orbital motion is too slow to detect without extremely precise measurements over many years. If you looked up at the sky one night and then looked up again 100 years later, it would appear exactly the same. The same stars in the same positions, shining with the same dim light. Even 1,000 years might not be enough to notice significant change. 10,000 years maybe. 100,000 certainly. Over those time scales, stars would have moved enough in their orbits that the sky would look different. Stellar streams would have shifted slightly, globular clusters would have progressed farther along their paths. But within a human lifetime, within even many human lifetimes, nothing would change. It's hard to imagine what that would do to consciousness. How it would affect your sense of time, your sense of progress, your sense of history. Without obvious markers of change, would time feel like it was passing at all? Would days blend together into an undifferentiated continuum, a perpetual present that never quite becomes past? Or would you become more attuned to subtle changes? Would you notice tiny shifts that would be invisible in busier environments? Would you develop a patience so profound that you could watch a star move across the sky over thousands of years and feel like you were watching something happen quickly? And there's no way to know without experiencing it. But the thought experiment is worth having, because it reminds us that our sense of time is relative, contextual, dependent on the environment we're in and the changes we're surrounded by. Time isn't an absolute thing we experience directly. It's something we infer from change. In the halo, in the deep emptiness, time would feel spacious, extended, like each moment has room to breathe, room to exist fully, without being crowded by the next moment rushing in. Like patience isn't something you practice, but something you embody, something you become. Let's talk about perspective now. About what it means to see the galaxy from outside, to float in the halo and look back at where you came from. From Earth, when we look up at the night sky, we see the Milky Way as a band of light stretching from horizon to horizon. We're inside it, embedded in the disk. So what we see is the galaxy edge on. We're looking along the disk as plane, seeing the combined light of billions of stars, all lying more or less in the same flat structure. It's beautiful. On a clear, dark night away from cities, the Milky Way is one of the most spectacular sights nature offers. A river of light flowing across the sky, dense in some regions, faint in others, marked by dark lanes where dust clouds block the light of stars behind them. It's our home galaxy, viewed from inside, and it's glorious. But we can never see its full structure from Earth. We can't see the spiral arms laid out, can't see how they connect and where they lead. We're too close, too embedded. It's like trying to understand the layout of a forest while standing in the middle of it. You see trees, certainly, lots of trees. But you can't see the shape of the forest, can't see how it relates to the landscape, can't perceive it as a coherent whole. From the halo, you could. From hundreds of thousands of light years away, floating in the emptiness, the Milky Way would reveal itself. You'd see it as a spiral galaxy, flattened and rotating, with arms curving outward from the central bulge. You'd see how the arms connect, how they're traced with young blue stars and glowing gas clouds, how they fade into fainter regions at their edges. You'd see the bulge glowing with the warm light of old stars, densely packed, rotating more quickly than the disk. You'd see it whole, complete, as an object, not as an environment. And seeing it that way, from outside, would change everything. All of human history, every civilization that has ever existed, every war ever fought, every discovery ever made, every story ever told, every person who has ever lived, all of it happened inside that structure. On a tiny planet orbiting an ordinary star in one of the spiral arms. So small that from the halo, it would be completely invisible. Not just hard to see, but impossible to see. Lost in the glare of billions of other stars, indistinguishable, insignificant. That realization could be crushing. It could make everything feel small and meaningless. What does any human concern matter when viewed from this perspective? What does any individual life matter when set against the scale of a galaxy containing hundreds of billions of stars? But here's another way to think about it. The Milky Way, for all its immensity, for all its billions of stars and its 100,000 light-year span, is fragile. It's held together by gravity, yes. But that gravity depends on the distribution of matter within it. Change that distribution significantly, and the structure changes. The disk might warp. The spiral arms might shift. The careful balance that allows stars and gas and dust to orbit in relatively stable patterns could be disrupted. From the halo, looking down at the galaxy, you could see it not as an eternal unchanging thing, but as a dynamic structure, evolving over time, shaped by its history, vulnerable to disruption. You could see it as something that exists now, but hasn't always existed in this form, and won't always exist in this form. The Milky Way is temporary. Not in human terms, it will last for billions of years yet. But in cosmic terms, eventually, it will collide with Andromeda. The two galaxies will merge, their stars mixing, their gas clouds colliding, their structures dissolving and reforming into something new. That will happen in about 4 billion years, give or take. From the halo, watching patiently enough, you could see it coming. You could see Andromeda growing larger, closer, its gravity beginning to distort the Milky Way's outer regions, pulling at the halo stars, creating tidal streams that stretch between the two galaxies like bridges. And that perspective, seeing the galaxy as temporary, as evolving, as part of a larger cosmic story, makes the small things matter more, not less. Because if the galaxy itself is temporary, and if even structures this vast are subject to change and transformation, then the brief sparkle of life on a small planet isn't insignificant. It's miraculous. It's a moment of incredible complexity and beauty arising in the midst of cosmic processes that are mostly about matter falling together and energy dispersing. Life is the exception. Consciousness is the exception. The ability to look up, to wonder, to try to understand. That's so rare in the universe that wherever it happens, however briefly, it matters. It matters absolutely. From the halo, floating in the emptiness, looking back at the distant spiral of the Milky Way, you could hold both truths at once. The truth of smallness, that we occupy an infinitesimal fraction of space and time, that we're made of common materials following common physical laws, that we're not central or special in any objective cosmic sense, and the truth of significance, that complexity is rare, that consciousness is precious, that the ability to experience wonder and create meaning is so unusual that it deserves recognition and protection wherever it emerges. Both truths, at the same time, without contradiction. That's what the halo's perspective offers, not the annihilation of meaning through scale, but the enrichment of meaning through context. There's a meditation practice common to several traditions, where you imagine yourself from increasing distances. First, you picture yourself as you are, sitting or lying where you are. Then you zoom out, imagining yourself from above, as if you could float up and look down on your own body. Then farther, your building, your neighborhood, your city, your region, your continent, your planet. As you zoom out, the details disappear. Your individual concerns become invisible. The specific circumstances of your life dissolve into the larger pattern. And there's a peace that comes with that dissolving, a recognition that your problems, while real and important to you, are also just part of a larger flow of existence that continues whether you solve them or not. The halo offers a version of that meditation on a cosmic scale. Zoom out far enough, and Earth disappears. Zoom out farther, and the solar system disappears. Keep going, and even the bright structures of the Milky Way become a distant object. Beautiful, but remote. No more important than any other galaxy in the cosmic web. And yet, zoom back in, which you can do at any time, instantly in imagination. And there you are again. The same person in the same place with the same immediate concerns. Nothing about the cosmic perspective changes your present reality. Your body still needs what it needs. Your life still has its challenges and joys. The people you care about still matter. The cosmic perspective doesn't replace the immediate perspective. It supplements it. It gives you a place to rest your mind when immediate concerns become overwhelming. A reminder that scale matters, that context matters, that the universe is large and old and patient, and that your moment-to-moment struggles, while valid, are also just moments. They'll pass. Everything passes. Stars pass. Galaxies pass. Even the universe itself will pass. Eventually, though that's so far in the future that the number of years involved becomes meaningless. But right now, this moment, you exist. You're here. You're conscious. You can think about the halo and imagine floating in its emptiness. You can contemplate distances that light takes thousands of years to cross. You can hold the vastness of the galaxy in your mind, even though your mind is tiny, contained in a few pounds of neural tissue inside your skull. That's not nothing. That's extraordinary. So float here a little longer. Float in the imagined emptiness of the halo. Let the darkness surround you. Let the silence seep into you. Let the distances stretch out in all directions until direction itself loses meaning, until there's only space and you within it, suspended, held, embraced by the patient arms of cosmic emptiness. Feel how it doesn't press on you, doesn't demand anything, doesn't threaten or challenge or ask you to be anything other than what you are. The emptiness is generous. It gives you room to exist without justification, room to be without explanation, room to simply float, breathe, rest. Your body, wherever it is safe, warm, supported. The emptiness you're imagining doesn't affect it, doesn't touch it. You can return to full awareness of your immediate surroundings anytime you choose. But for now, while we're here together, you can let yourself drift. Let the halo hold you. Let its ancient stars keep watch. Let its dark matter weave its invisible support beneath and around you. Let the vast distances remind you that spaciousness isn't lack, it's freedom. Let the silence remind you that peace doesn't require noise to validate it. Let the darkness remind you that rest is the natural state, that light is the exception, that closing your eyes and surrendering to the dark is one of the most natural things you can do. The halo has existed for billions of years. It will exist for billions more. It's patient. It understands that some journeys take time, that some rest is measured in dreams rather than hours, that floating in the space between stars is just another way of saying floating in the space between thoughts, between heartbeats, between moments. You belong here, in this emptiness, in this silence, in this peace. Not forever. You have a life to return to, a world that needs you, people who care about you, purposes to fulfill. But for now, for this moment that stretches as long as you let it stretch, you belong here, in the halo of silence, where the galaxy thins and stillness becomes infinite, and where you, small and temporary and miraculous, can finally rest. How do astronomers study something so empty, so dark, so far from where we live? How do you examine silence? How do you measure emptiness? How do you map the invisible? answer reveals something profound about human curiosity, about our refusal to accept that distance or darkness can prevent understanding. We can't travel to the halo, not with our current technology, not within any time frame that makes sense for human lives. But we've learned to study it anyway, to piece together its story from the faint clues that reach us across the void. Let's talk about how we do that. Not with urgency or technical complexity, but gently, the way you might describe how a detective solves a mystery, or how an archaeologist reconstructs an ancient civilization from fragments and hints. Because that's really what astronomy is. Detective work on a cosmic scale. Reading stories written in light. The first and most fundamental tool we have is light itself. Everything we know about the universe beyond our immediate reach comes from light. From electromagnetic radiation in all its forms. Visible light, yes, but also infrared, ultraviolet, radio waves, X-rays, gamma rays. Different types of light tell us different stories, reveal different aspects of cosmic structures. When we study the halo, we start with the most obvious light. The light from stars. Those ancient red stars scattered through the emptiness, the globular clusters orbiting in their long paths, even the faint stellar streams stretching across space. They all emit light, and that light travels across the void until some of it reaches Earth, where we can capture it with telescopes and analyze it. But here's what makes this remarkable. We don't just see that light, we read it, we decode it. We extract information from it that tells us stories about objects so distant that their light began its journey before human civilization existed. Every beam of starlight is a message, and astronomers have learned to read the language. When light passes through or near matter, it carries information about that matter. If light passes through a cloud of gas, certain wavelengths get absorbed. The gas atoms grab those specific colors out of the beam, leaving dark lines in the spectrum. The different elements absorb different wavelengths, creating a unique fingerprint. By analyzing which wavelengths are missing from a star's light, we can determine what elements are present in that star's atmosphere, what temperature it is, how fast it's moving toward or away from us, even how old it might be. It's like receiving a letter that's been partially redacted, with certain words blacked out. But if you know the pattern of what's missing, you can deduce enormous amounts about who wrote the letter and where it came from. The ancient stars of the halo have a distinctive signature. They're what astronomers call metal poor, which sounds strange because metals in astronomy means anything heavier than hydrogen and helium. These old stars formed in the early universe, before many generations of stars had lived and died, before supernovae had scattered heavy elements throughout space. So they contain mostly hydrogen and helium, with only traces of heavier elements. When we analyze their light, we see that signature. We see the absence of certain absorption lines that would indicate iron, carbon, oxygen, nitrogen, the elements that are common in younger stars like our sun. And that absence tells us a story. It tells us these stars are old, ancient, formed in a different era of cosmic history, when the universe itself was young and the periodic table hadn't been fully populated yet. Every star in the halo carries this chemical fingerprint. And by studying enough of them, by cataloging their compositions and positions and motions, astronomers can reconstruct the history of how the galaxy formed, how it evolved, how it consumed smaller galaxies and mixed their stars into the halo population. It's cosmic archaeology, written in light. But reading the light from individual stars only tells you so much. To really understand the halo structure, you need to know where stars are and how they're moving. you need to map the three-dimensional distribution of matter across hundreds of thousands of light years. That's harder than it sounds. When you look at the night sky, you see stars scattered across a two-dimensional surface, the celestial sphere. But that's just a projection. Every star is at a different distance, and figuring out those distances is one of the fundamental challenges of astronomy. For nearby stars, within a few hundred light years, astronomers can use a technique called parallax. As Earth orbits the Sun, our perspective shifts slightly. Nearby stars appear to move against the background of more distant stars, the same way a nearby tree seems to shift position relative to distant mountains when you walk past it. By measuring that tiny shift and applying some geometry, you can calculate the distance. But for halo stars, which are thousands or tens of thousands of light years away, parallax becomes too small to measure accurately with most telescopes. The shifts are so tiny that they're lost in the noise of measurement errors. You need other methods. One approach is to use standard candles, objects whose intrinsic brightness you know. If you know how bright something actually is, and you measure how bright it appears from Earth, you can calculate how far away it must be. Farther objects appear dimmer, following a precise mathematical relationship called the inverse square law. Certain types of variable stars serve as standard candles. Cepheid variables, for instance, pulsate with a period that's directly related to their luminosity. Measure the pulsation period, and you know the star's true brightness. Compare that to its apparent brightness, and you can calculate its distance. Auroral Lyrae variables, which are common in globular clusters, work similarly. By measuring distances to thousands of these stars, astronomers can map the three-dimensional structure of the halo. They can determine where globular clusters are, how far they are from the galactic center, what paths they're following through space. And once you know where things are, you can start to see patterns. You can see that globular clusters aren't randomly distributed, but form a roughly spherical halo around the galaxy. You can see that certain stellar streams stretch across specific regions, marking the orbital paths of disrupted galaxies. You can see structure emerging from what initially looked like random scatter. It's like watching a picture slowly develop. At first, you have just a few points of data, dots of light scattered across the darkness. But as you add more data, more measurements, more observations, the picture becomes clearer. Patterns emerge. Structure reveals itself. The invisible becomes visible, not through direct observation, but through careful inference and patient accumulation of evidence. But what about the dark matter? How do you study something that doesn't emit any light at all, that doesn't interact with light, that's invisible by definition? This is where astronomy becomes truly beautiful, truly clever. Because even though we can't see dark matter directly, we can see what it does. We can detect its presence through its gravitational effects, the way it influences visible matter. Imagine you're in a dark room and someone throws a ball to you. You can't see the ball, it's too dark, but you can hear it moving through the air. You can tell where it is by the sound it makes, and when you catch it, you can feel its weight and texture. You've detected the ball without ever seeing it. Dark matter is similar, except instead of sound, we use gravity. And instead of catching it, we watch how it bends space and affects the motion of things we can see. One of the most striking pieces of evidence for dark matter comes from rotation curves, measurements of how fast stars and gas orbit in galaxies. According to Newton's laws, objects farther from the center of a galaxy should orbit more slowly, the same way outer planets in our solar system orbit more slowly than inner planets. But when astronomers measured actual rotation speeds, they found something strange. Stars in the outer regions of galaxies move much faster than they should if only visible matter were present. The only explanation that makes sense is that there's additional mass we can't see, dark matter, distributed throughout and around the galaxy, providing extra gravitational pull that keeps those outer stars moving fast without flying off into space. In the halo, this dark matter dominates. As we mentioned before, it probably outweighs visible matter by a factor of 10 or more. The stellar halo, all those ancient stars and globular clusters, is just the visible part of a much more massive dark matter halo. We can map the distribution of this dark matter by observing how it affects visible structures. When light from distant galaxies passes through or near massive concentrations of dark matter, the light's path bends, a phenomenon called gravitational lensing. The dark matter acts like a lens, distorting and magnifying the light, creating multiple images or strange arcs and rings in the sky. By studying these gravitational lensing effects, astronomers can map where dark matter is concentrated, how it's distributed, how massive different regions are. They can create maps of the invisible, charts of matter that has never emitted a single photon, but shapes the structure of everything around it. These maps reveal something astonishing. The dark matter halo isn't smooth or uniform. It has structure, clumps and streams and voids. A complex three-dimensional pattern that reflects the galaxy's violent history of mergers and interactions. Some of this structure comes from smaller dark matter halos that were part of the dwarf galaxies consumed by the Milky Way. When a small galaxy gets torn apart, its stars form stellar streams, but its dark matter forms dark matter streams, invisible rivers of matter flowing through the halo, detectable only through their gravitational effects. It's a hidden landscape, a secret geography that underlies the visible structures we see. The halo, it turns out, is far more complex than the scattered stars suggest. Beneath the apparent emptiness is a rich tapestry of invisible matter, organized in patterns we're only beginning to understand. There's another way we study the halo, one that involves looking not just at what's there now, but at what used to be there. Stellar archaeology, it's sometimes called. The idea is simple but powerful. Stars remember where they came from. When a star forms, it incorporates elements from the gas cloud that gave birth to it. That gas has a specific chemical composition determined by the history of star formation in that region. If the star formed in a galaxy that had experienced many generations of star formation, with multiple supernovae enriching the gas with heavy elements, the star will have a relatively high metal content. If it formed in a small, young galaxy that hadn't had time for much chemical enrichment, it will be more metal poor. Even after that small galaxy is destroyed and its stars are mixed into the Milky Way's halo, those stars retain their original chemical signatures. By analyzing the composition of halo stars, astronomers can group them into families, stars that probably came from the same original galaxy, even though that galaxy no longer exists. It's like doing a DNA test thousands of years after a migration event. You can identify which people share common ancestry, even though the original homeland is gone and the migration routes are forgotten. The genetic signatures persist, encoded in every cell. Similarly, chemical signatures persist in stars, encoded in their light. By studying enough halo stars, measuring their compositions, comparing the patterns, astronomers can reconstruct the Milky Way's family tree. They can identify perhaps dozens of separate merger events, each one representing a smaller galaxy that was consumed billions of years ago. They can estimate when these mergers happened, how massive the progenitor galaxies were, even what direction they approached from. The halo becomes a fossil record. Its stars are relics from a more chaotic time in galactic history, preserved nearly unchanged for billions of years, waiting for us to learn how to read their stories. And we have learned. We're learning still. Every new survey, every new generation of telescopes, every new analytical technique reveals more details, more structure, more history embedded in the halo's apparent simplicity. There's something profound about this whole endeavor. Think about what's actually happening. Human beings, living on a small rocky planet orbiting an ordinary star in the disk of a spiral galaxy, using instruments made from refined cosmic materials, are studying regions of space hundreds of thousands of light years away. Regions they will never visit, can never touch, can barely even imagine in any concrete sense. And yet, we can understand them. We can map them, measure them, reconstruct their history, predict their future. We can study invisible matter through its gravitational effects. We can determine the age and composition of stars from their light. We can trace the paths of galaxies that were destroyed billions of years ago. All of this from our tiny vantage point, using nothing but light and mathematics and patient, careful observation. It's one of humanity's greatest achievements. Not a technological achievement, though technology is involved. Not even purely a scientific achievement, though science is the method. It's an achievement of imagination and persistence. A refusal to accept that distance or darkness can prevent understanding. The halo is far away, but we've learned to reach it with our minds, with our instruments, with our questions. We've learned to make the invisible visible, the distant near, the silent eloquent. And we've done it not through conquest or domination, but through listening. Through paying attention to faint signals that have traveled across vast distances to reach us. Through learning to read messages written in light. To hear stories told by the motion of matter. To see patterns in what seems like random scatter. That's worth acknowledging, worth appreciating. Human curiosity has carried us far beyond our physical reach. Our minds have traveled to the edge of the galaxy and beyond, even while our bodies remain here, on this small world, in this quiet corner of the cosmic neighborhood. You don't need to remember all the technical details. You don't need to be able to explain gravitational lensing or parallax measurements or stellar spectroscopy. Those are just tools, methods, ways of extracting information from the universe. What matters? What's worth carrying with you into sleep or into waking is the broader truth. That distance doesn't mean disconnection, that we can understand things far beyond our reach, that the universe, vast and ancient and mysterious as it is not fundamentally unknowable. It speaks to us constantly in the language of light and gravity, and we've learned to understand that language. The halo may be far away, may be mostly empty, may be dominated by invisible matter we still don't fully understand. But it's not alien. It's not separate from us. It's part of the galaxy we live in, the structure that holds our solar system in its gravitational embrace, the echo of cosmic events that happened billions of years before Earth existed. And we can study it. We have studied it. We continue to study it, learning more with each passing year, each new observation, each refinement of our instruments and methods. The silence of the halo isn't the silence of the unknowable. It's just the quiet of something waiting patiently to be understood, revealing its secrets slowly to those who learn how to listen. So as you rest here, in your comfortable spot, in your safe place, you can carry this knowledge with you. The halo exists. It surrounds our galaxy in a vast, dark embrace. Ancient stars drift through its emptiness. Dark matter weaves its invisible structure through the darkness. Globular clusters trace their patient orbits. Stellar streams mark where galaxies were torn apart billions of years ago. All of this is real. All of this is happening right now, while you breathe quietly and let your thoughts drift. The universe doesn't stop when we close our eyes. It continues its slow, patient unfolding. And humans, tiny and temporary as we are, have learned to watch that unfolding, to measure it, to understand it. We've learned to reach beyond our immediate surroundings and touch, at least with our minds, the vast structures that dwarf us. That connection between the human mind and the cosmic darkness, between our small scale and the galactic scale, between the known and the unknown. That connection is what makes astronomy more than just a science. It's a way of participating in the universe, of being part of the story even while observing it. You're part of that story too. The atoms in your body were forged in stars, some of them perhaps in halo stars, ancient suns that burned for billions of years before dying and releasing their matter back into space. That matter mixed, traveled, eventually found its way to the gas cloud that would become our solar system. And now it's here, arranged into the intricate pattern that is you, conscious and aware, and able to think about the place where those atoms were born. The halo isn't distant in that sense. It's connected to you through the deep history of matter, through the way the universe recycles everything, using and reusing the same basic building blocks to create stars and planets and people. Rest in that connection. Let it comfort you. You're not separate from the cosmic darkness. You're made of it. Part of it, connected to it through history and chemistry and the patient flow of matter through time. The halo studies us just as much as we study it, not with instruments or intention, but simply by being the place our atoms came from, the structure that holds our galaxy together, the embrace that surrounds everything we know. Halo of silence, floating beyond the edge of the Milky Way. Chunk 5. The final drift home, $5,000, 6,000 words. Softest tone yet, like a lullaby. This is the goodbye, the release, the permission to fully let go. We've been traveling together for a long time now, floating in imagination through the vast emptiness of the galactic halo, hundreds of thousands of light years from where your body rests. We've drifted past ancient stars in globular clusters. We've traced the ghostly paths of stellar streams. We've felt the patient presence of dark matter holding everything together with invisible hands. We've experienced the silence, the darkness, the profound peace of cosmic emptiness. And perhaps now, it's time to begin the long, slow drift home. Not because we must, not because there's any urgency or schedule to keep, but because even the longest journey eventually curves back toward its beginning. Even the farthest travelers eventually turn their faces homeward, carrying with them the memories of distances crossed and silences experienced. So let's begin, but slowly. So slowly that you might not even notice we're moving. Because the return from the halo isn't like falling back to Earth. It's more like settling. Like watching something dissolve gently into water. Like the way sleep creeps up on you when you're not paying attention. One moment you're awake, and the next you've drifted somewhere else entirely without noticing the transition. Extremely slow, deliberate pacing from here on. Before we leave this place, let's take one more look around. One final moment of appreciation for where we've been, what we've seen, what we've felt in this journey to the edge of everything familiar. Look down, or what passes for down in the three-dimensional emptiness of space. and see the Milky Way spread out below us. That distant spiral of light, glowing softly against the cosmic darkness. From here, you can see its full structure. The bright central bulge, dense with ancient stars. The graceful spiral arms curving outward, traced with the blue light of young stars and the red glow of nebulae where new suns are being born. The flattened disk, spinning slowly, completing one rotation every few 100 million years. It's beautiful from this distance. Beautiful in a way it can never be when you're inside it, when you're too close to see the pattern, when you're embedded in the structure itself and can only see pieces and fragments rather than the coherent whole. Somewhere in one of those spiral arms, you can't see which one from here. It's too small, too far. Lost in the glow of billions of other stars, somewhere there is a yellow star. Ordinary, unremarkable, burning its hydrogen fuel the way it has for nearly 5 billion years, the way it will continue to do for another 5 billion years or so before exhausting its fuel and beginning its slow transformation into a red giant. Around that star orbit, 8 planets, rocky inner worlds, gas giants farther out, ice worlds at the edge where sunlight is faint and cold. And one of those rocky inner worlds, the third one from the star, has something extraordinary on its surface. Something so rare in the universe that we've only confirmed it exists in one location, though we suspect it might exist in others. Life, oceans full of it, land covered with it, air shaped by it. Life in more forms than you could name in a lifetime, each one adapted to its particular niche, each one connected to all the others through vast networks of eating and being eaten, of cooperation and competition, of chemical cycles and energy flows. And one species among all those forms, hairless primates who learn to walk upright, to use tools, to speak and write and calculate and wonder. One species that looked up at the night sky and asked questions, who wondered what those points of light were, who invented mathematics to describe them and built instruments to study them and developed theories to explain them, who learned, eventually, that they were living on a planet orbiting a star in a galaxy of hundreds of billions of stars, who discovered that their galaxy was one among hundreds of billions of galaxies in an observable universe so vast that human language struggles to capture its scale, who learned all of this despite being confined to a single small world, using nothing but light and thought and patient observation. That's where you came from. That tiny, invisible point in the spiral structure below us. That's home. Not just your physical home, your house or apartment or wherever your body currently rests, but your cosmic home, the planet that gave birth to your species, the world that shaped everything about how you perceive reality. Earth. From the halo, it's invisible, completely and utterly invisible. You could search for years with the most powerful telescopes imaginable and never find it, because it doesn't emit enough light to distinguish itself from the billions of other planets that surely orbit billions of other stars throughout the galaxy. But it's there, spinning peacefully in the darkness, wrapped in its thin film of atmosphere, home to everyone you've ever known and everyone who has ever lived. All of human history, all the empires and dynasties, all the wars and peace treaties, all the love stories and tragedies, all the scientific discoveries and artistic masterpieces, all the ordinary lives lived in quiet dignity. All of it happened on that invisible speck. From here, from the halo's vast perspective, Earth's invisibility could seem sad, a reminder of cosmic insignificance, of how small we are against the scale of the universe. But there's another way to see it. That tiny, invisible world produced consciousness capable of imagining this very moment, capable of picturing itself from hundreds of thousands of light years away, floating in the halo, looking back at its home, capable of understanding the structure of galaxies, the physics of gravity, the history written in starlight. The universe is mostly empty space and simple matter following simple rules. Stars burn. Gas clouds collapse. Gravity pulls things together. It's all mechanical, deterministic, predictable. But somehow, in at least one location that we know of, matter organized itself into something that could look back at all that mechanism and find it beautiful, that could study it, understand it, create meaning from it. That's not insignificant. That's miraculous. Pause for 5 seconds. As we begin our drift back toward that invisible world, let's talk about what the halo has taught us, not facts and figures. We've covered plenty of those already, and you can let those details dissolve if they want to dissolve. But the deeper lessons, the things that might stay with you even after the specifics fade, the truths that the halo embodies just by existing. First, emptiness is not the same as absence. The halo seems empty when you first encounter it, vast spaces with almost nothing in them, but we've learned that it's full of invisible structure, full of dark matter and ancient stories, and the echoes of cosmic events billions of years old. What looks like nothing is actually something if you learn how to perceive it. Maybe that applies to other kinds of emptiness too. Quiet moments that seem like wasted time might be opportunities for rest and restoration. Periods of life when nothing seems to be happening might be when important internal changes are taking place. Invisible, but essential. Emptiness might be space for possibility rather than absence of meaning. Second, distance is relative, and connection doesn't require proximity. The halo is far from the disk, far from the busy regions where stars are born and die in dramatic fashion. And yet it's connected to all of that through gravity, through shared history, through the chemical fingerprints that link halo stars to their origins in long-destroyed galaxies. Separation doesn't mean isolation. You can be far from something and still be part of it. Think about that when you feel disconnected from people or places you care about. Physical distance doesn't break the bonds that matter. The connections persist even when you can't see them, even when you can't feel them directly. Like dark matter, like the gravitational embrace of the halo, some connections are invisible but unbreakable. Third, patience is not just waiting. It's a way of being. The halo operates on timescales so long that human lifespans are barely perceptible. Stars take hundreds of millions of years to complete their orbits. Stellar streams persist for billions of years before finally dissolving. Nothing happens quickly, and nothing needs to. In a world that often demands speed, efficiency, constant productivity, the halo reminds us that some things can only happen slowly, that there's wisdom in taking your time, in letting processes unfold at their own pace, in not forcing or rushing, but simply allowing. You don't have to be productive every moment. You don't have to achieve constantly. Sometimes, the most important thing you can do is simply exist, rest, restore yourself. Be patient with yourself the way the halo is patient with its stars, giving them millions of years to complete their journeys, never rushing, never demanding. Fourth, silence is a gift, not a void. We live in a noisy world. Even in quiet moments, there's usually sound, traffic, appliances, the hum of electricity, other people, our own internal chatter. True silence is rare and often uncomfortable. We rush to fill it with music or conversation or anything that breaks the quiet. But the halo has taught us that silence can be profound, peaceful, restorative. The emptiness of space, the absence of sound waves, the vast quiet of cosmic distances. It's not threatening. It's restful. It's the natural state that sound interrupts, not a void that sound fills. Maybe silence deserves more appreciation, more intentional seeking, more trust that it will hold you rather than swallow you. And finally, you are both infinitesimally small and unimaginably significant. The halo makes both truths visible simultaneously. From its perspective, Earth vanishes. Human concerns become invisible. The scale is so vast that individual lives seem to lose meaning entirely. And yet, those individual lives, your life, are where meaning is created, where consciousness experiences wonder, where the universe becomes aware of itself. The fact that you can float in imagination through the halo, can contemplate cosmic emptiness, can understand distances measured in hundreds of thousands of light years, is itself a miracle that justifies your existence. You are small, that's true, but you are also capable of holding vastness in your mind. And that makes you significant in a way that mere size can never capture. Softer still, like tucking someone in. These lessons from the halo, you don't have to consciously remember them. They're not homework. They're not things to quiz yourself on later. Let them settle into you the way starlight settles on a planet's surface, gentle and persistent, accumulating slowly, changing things in ways too subtle to notice moment by moment, but profound over time. And as they settle, let us continue our drift homeward, not falling, not rushing, just settling. The way autumn leaves drift down through air, the way sand settles through water, the way sleep settles over your awareness when you stop resisting it. We're passing back through the regions we traveled through earlier, but everything looks different now. Or perhaps we look at them differently, having spent time in the deepest emptiness, having felt the full weight of cosmic silence. The scattered halo stars seem less lonely now and more peaceful. The globular clusters seem less like isolated islands and more like communities that have found their place in the vastness. The stellar streams seem less like scars of destruction and more like memories made visible, history written in stars. We drift past regions where dark matter flows in invisible currents, and we can almost feel it now, even though it will never touch us, even though it passes through normal matter without interacting. We can sense its presence the way you can sense someone standing behind you, even when you can't see them. The gravity of it, the weight of it, the patient holding that keeps the galaxy from flying apart. Thank you. We might whisper to the dark matter. Thank you for holding everything together. Thank you for your invisible service, your patient presence, your gift of structure to matter that would otherwise scatter into the void. And the dark matter, of course, doesn't respond. It has no awareness, no consciousness, no ability to receive thanks. But perhaps the act of giving thanks matters more than whether it's received. Perhaps gratitude itself has value, regardless of its object. We drift closer to the disk now. Close enough that individual stars become visible again, not just the collective glow of billions. Young blue stars that will burn bright and die quickly. Yellow stars like our sun, middle-aged and stable. Red giants that have already exhausted their core hydrogen and expanded to enormous sizes. Their outer layers diffuse and cool while their cores compress under their own weight. Each one a world unto itself. Each one following its own path through space. Influenced by gravity and chemical composition and the accidents of its birth. Each one shining, some brightly, some dimly, but all of them transforming mass into energy through nuclear fusion, the same process that has powered the universe since the first stars ignited in the cosmic dawn. We're close enough now that we can see the spiral arms more clearly. They're not solid structures. Stars aren't packed densely enough for that. They're density waves, regions where stars and gas crowd together slightly more than average, making them visible as bright features when you step back far enough to see the pattern. The arms rotate, but more slowly than the stars themselves. So stars drift in and out of the arms over millions of years, spending some time in the bright regions and some time in the darker spaces between. Our sun has drifted through several spiral arms during its lifetime. It's been in bright neighborhoods and dim ones, crowded regions and sparse ones, always moving, always orbiting, completing that long circuit around the galactic center every 230 million years or so. And through all those changes, through all those different galactic neighborhoods, Earth has remained, orbiting faithfully, maintaining its distance from the sun, rotating on its axis, circling through seasons, supporting life generation after generation. Constant in its inconstancy, reliable in its changes. Whisper soft, as if sharing a secret. We're almost home now. Almost back to the familiar scale, the comfortable distances, the world you know. The spiral arm where we live, the Orion Spur, is just ahead. A relatively quiet region, not too crowded, not too empty. Far enough from the galactic center to avoid the chaos and radiation of that dense environment, but not so far out that we're isolated in the galactic suburbs. A good neighborhood for life. Safe, stable, peaceful enough that evolution can proceed without constant disruption from nearby supernovae or close stellar encounters. Lucky, in a way. Or perhaps not luck. Perhaps in a galaxy with hundreds of billions of stars, there are millions of neighborhoods like ours, and life arises in the ones where conditions permit it. We notice our own good fortune because we're here to notice it, but we're here because the conditions were right. A kind of cosmic circular reasoning, but no less true for being circular. And there, can you see it? That yellow star, neither particularly bright nor particularly dim, burning steadily as it has for billions of years. That's the sun, our sun, the star that powers everything on Earth, that provides the energy for photosynthesis and weather and ocean currents, and ultimately for every living process on the planet. From the halo, it was invisible. From the disk, it's still not remarkable. One star among billions. But from here, as we drift closer, it begins to look special. Not because it's objectively different from millions of other stars, but because it's ours. Because it matters to us. Because our story is tied to it in ways too profound and numerous to fully articulate. Around that sun, too small to see separately, even from this close vantage point, orbit the planets. Mercury, scorched and cratered. Venus, hidden beneath toxic clouds. Earth, blue and white and green, wrapped in its precious atmosphere. Mars, red and cold and dry. The gas giants farther out. Jupiter, Saturn, Uranus, Neptune, each one a world of its own complexity. And the smaller objects beyond, dwarf planets and comets and asteroids, the remnants of the solar system's formation, the leftover building materials that never got incorporated into planets. All of it orbiting the sun in a complex but predictable dance, held together by gravity, following paths determined by mass and velocity and the patient laws of physics that govern all motion throughout the universe. Slower still, like the last sentences before sleep. And there is Earth, smaller than Jupiter, smaller than Saturn, smaller even than Uranus and Neptune, but perfect for our purposes. Rocky and solid, warm but not too warm, cool but not too cool. With liquid water on its surface and an atmosphere thick enough to retain heat, but thin enough to allow sunlight through. A world that looks, from space, like a work of art, white clouds swirling in complex patterns, blue oceans covering most of its surface, brown and green continents outlined by coastlines that have shifted slowly over hundreds of millions of years as continents drift and collide and break apart. The whole planet glowing in reflected sunlight, a beacon of habitability in the cosmic darkness. Home. We drift closer still, close enough to see the curve of the horizon, the thin line of atmosphere that separates the surface from space. That atmosphere, mostly nitrogen and oxygen, with traces of other gases, is so thin that if Earth were the size of an apple, the atmosphere would be thinner than the apple's skin. And yet, it's everything. It's what makes life possible, what protects the surface from harmful radiation, what distributes heat from the equator to the poles, what carries water through the hydrological cycle. Precious, fragile, essential. We descend through it now, through the layers of air that grow thicker and warmer as we approach the surface. Through the region where auroras dance when solar storms strike. Through the layer where meteors burn up, protecting the surface from constant bombardment. Through the layer where weather happens, where clouds form and rain falls and winds blow. Down to the surface, to the land or sea, wherever you are. To the particular place on this planet where your body has been resting this whole time, safe and warm. Breathing that precious atmosphere held by gravity against the planet's surface. Protected by all the layers and systems and processes that make Earth habitable. You're back. You never left. Not really. Your body has been here all along. But your mind traveled far. To the edge of the galaxy and beyond. To the halo of silence where ancient stars drift and dark matter flows, and emptiness stretches for hundreds of thousands of light years in every direction. And now you're back, carrying those distances inside you, carrying that silence, that peace, that cosmic perspective. It's part of you now, even if you don't consciously remember every detail. The halo has touched you, and you've touched it. And that exchange persists, even as the specific memories fade, barely audible now, like the last whisper before sleep. Your body knows what to do now. It knows how to rest, how to let go, how to surrender to sleep if sleep is what you need. Your breath slows naturally. Your muscles relax without effort. Your thoughts, which have been traveling through cosmic distances, begin to settle like leaves, drifting down through still air. The halo surrounds you still, even here. Not physically, it's hundreds of thousands of light years away. But in memory, in awareness, in the part of your mind that now knows what vast emptiness feels like. You can return there anytime you want in imagination, when you need spaciousness or silence or the perspective that only cosmic distances can provide. It will always be there, patient, quiet, waiting. The ancient stars will continue their long orbits. The dark matter will continue holding the galaxy together. The globular clusters will drift through their paths. The stellar streams will trace their ghostly arcs across the void. All of it happening whether you're aware of it or not. Whether you're awake or asleep, whether you're thinking about it or focused on the immediate concerns of your daily life. The universe continues, patient, vast, indifferent but not hostile. Simply existing, following its laws, unfolding its patterns across scales of time and space that dwarf human comprehension. And you are part of it, made of it, connected to it through the atoms in your body, through the gravity that holds you to Earth's surface, through the light that has traveled from the sun to warm your face, through the cosmic history that led from the Big Bang to this moment right now, where you rest and breathe and slowly release your grip on wakefulness. Sleep now, if if sleep is calling, or simply rest. Let the halo hold you in its distant embrace. Let its silence become your silence. Let its peace become your peace. Let the vast emptiness remind you that you have space. Space to exist, space to rest, space to simply be without needing to do or achieve or prove anything. The galaxy turns slowly beneath you. The stars keep watch. The darkness surrounds everything with its patient presence. And you are exactly where you're meant to be, in this moment, on this planet, in this galaxy, surrounded by silence.